Now we will move on to trigonometric identities. And there are two main identities that you need to know in AS. Sine squared x plus cosine squared x equals 1, and it always equals 1. The three lines means always equals. Tan x always equals sine x over cosine x. And let's do some proofs for them. We'll pull up the trusty unit circle and I'll just draw up something here. And we know that this length is sine x and this is cosine x and this is 1. So easy, Pythagoras, sine squared plus cosine squared x equals 1 squared, which is just 1. That is very easy. Now we will extend this out and we'll do our tan because we know that this is 1 tan theta. Now, in a similar triangle, the ratios of side lengths are the same. So we know that sine of x over cosine x, well, maybe I might do some colour here, and I'll shade each of the corresponding sides. So sine x over cosine x will equal tan x. Well, remember this theta can be replaced with x. I should probably say tan of x and then call this angle x. And what's this length? Well, we know that it's a unit circle, so this will be 1. So then that's why sine of x over cosine x is equal to 1. Sorry, not 1. It's equal to tan x. Yep. Now, you will have to use those two identities to prove other identities. For example, you may have to prove something like this. That cosine squared x minus sine squared x over cos x minus sine x is always equal to cosine x plus sine x. And what you would write is you'd write left hand side and you'd choose the more complicated one, which is this one. And then you just work algebraically and with those identities to get to the right hand side. So we know that often with trig identities, you may need to use difference of two squares, and that's very useful. And so we write the top as cosine x plus sine x, bracket cosine x minus sine x, that's factorising. And we divide it by cosine x minus sine x. Now these bits cancel out, so that's equal to cosine x plus sine x, and that's equal to the right hand side, and that's QED. We've completed that proof. And so remember that a squared minus b squared is equal to a plus b, a minus b. Difference of two squares. Not a great example because it doesn't actually require the use of trig identities, so we'll do a better example later. Now, sometimes you could get given an identity, you have to prove it, and then you use it to solve an equation. For example, sine theta over 1 plus cos theta plus 1 plus cos theta over sine theta is equal to 2 over sine theta. And then it asks you to solve this being equal to 1 plus 3 sine theta, and it gives you a domain like 0 degrees, 360 degrees. And basically, what you'd do is you'd prove this, and then you just do 2 sine theta equals 1 plus 3 sine theta, and you'd rearrange it and solve. And I should note here that if you can't prove this, it's good. Well, it's not good, but it's okay, because you can still skip to this part and get marks there. So let's go ahead and prove this. We'll go left-hand side. That last example, you didn't even need to use trig identities. So we'll just see if this one can. And so that will be equal to, well, let's see what we can do. Let's try and combine this into one fraction. This would be sine squared theta over sine theta plus cos theta. And we're adding 1 plus cos theta squared onto that, I believe. Yep. And so we're trying to get it into sine, actually. So we will perhaps expand one of them. So it's sine. Oh, 2 of sine. We'll see if we can get these cosines to cancel out. So I would perhaps write. It takes a bit of trial and error. Don't get me wrong. And then we'll expand this. And remember, I've used this identity of 1 minus sine squared theta will equal cosine squared theta. Those cos squared and those cos squareds will eliminate, leaving us with 2 cos theta plus 2 over 1 plus cos theta multiplied by sine theta. We'll factorize, and that cancels. So we get 2 over sine theta, which equals the right hand side, QED. And I'll just do one that uses tan. So the left hand side equals cosine theta over tan theta 1 plus sine theta. And remember that tan theta equals sine theta over cosine theta. So cosine theta is sine theta over tan theta. Or that. well, tan is sine over cosine, so probably we'll do that instead. We'll replace tan with sine theta over cosine theta. And so, yeah, that will lead us, because when we're dividing by something, we multiply the reciprocal, so you have to get cosine squared on the top, and then sine theta 1 plus sine theta. We'll leave it factorised for now. So that will give us, because that cosine squared theta will just be 1 minus sine squared theta, and over sine theta, 1 plus sine theta. Oh, we use difference of squares again, 1 plus sine theta, multiplied by 1 minus sine theta, over sine theta, 1 plus sine theta. That's 1 minus sine theta over sine theta. And that can be simplified to 1 over sine theta minus 1, which equals the right-hand side, QED. That's a few examples. I'll leave you to practice more.